So in order for us to be finding the inverse to be a function, we need to restrict the domain to just that little piece right there. Now, when you switch the x's and y's, so this is your restricted tangent function. As we discussed in the notes earlier, why do we want the points in quadrant 1? Because they fit nicely inside of a right triangle. What section of that graph is fitting nicely inside of a right triangle? Is it this section or is it this section? 0 to power 2, right? 0 to power 2, those are the angles that fit nicely in a right triangle. We also want it to be connected together. So if you decided to do 0 to pi, like this right here, just like the inverse cosine function, or what would happen? Wouldn't you have a piece that was like here? That would have the correct range, which is fantastic, but it would be split right down the middle. So we don't like that. So just like the sine inverse, we decided to go backwards and add on this direction. And look, we have a continuous piece that has the correct range. So now we switch x and y. That's what an inverse function does. It switches x and y. Okay, so we switched x and y. What does that do to these asymptotes? If they were vertical asymptotes on the old one, what are they going to be now? Horizontal. Nicely said. And I'm going to do this in blue just to kind of, we're going to end up getting a shape that kind of does this. Because when you switch x and y, you should get a reflection across what line? What line? Y equals x, right? So you should be getting a shape, and according to my scale, you should be getting a shape that kind of looks like this. That's a little bit crude, but you get the idea. What's the domain of this function? What's the domain of the graph we see? The inverse. All reals. It definitely would be a cool tattoo. It would. Right here on the inside of my bicep. The all real number symbol right here. Okay. Now if I did that, which I'm too scared to get a tattoo, but if I did that, I put the all real number symbol right here. You know what would be on the other one, right? The symbol for the natural numbers, right? The capital N with a double bar, right? Because it's all natural. Okay, but I'm too scared for that kind of stuff, so I won't be doing that. I mean, the tramp stamp at the quadratic formula on my back is just, that's good enough right there, you know? Okay. What? A singer? No, I am the math preacher. Like when I fill out a form, you know, and it says occupation, I just put math preacher. Yeah, that's my Twitter, Math Preacher JR. On the back of your neck. Oh, yeah. Let's just like put it around my neck. Okay, so what's my range? We talked about the range a few seconds ago. Okay, now, quick question. What am I going to put on either side of those? Parentheses, thank you very much. I headed it over here on my right. Not sure. Okay. Not including the endpoints. Okay, that does go along with the idea of the restricted domain here, which was negative pi over 2 to pi over 2, with a range of all reals.
Okay, obviously we see that they switched because we switched x and y. That happens every time you switch x and y. The domain and range switch. It kind of makes sense. Okay. At first this will seem weird, but we'll get the idea here. Compose each of the 6 basic trig functions with sine inverse x and reduce the composite function to an algebraic expression involving no trig functions at all. I know you don't understand what they just said. Okay, so I need you to focus your attention right there, sine inverse x. And I'm going to zoom in on it a little bit, okay? No, that's not what I meant, okay? What I mean by that is this. Most of you don't realize that what they are really talking about is sine inverse of x over 1. You know that anything can be divided by 1, correct? So look at how they built the triangle. Why do you think they labeled the right side x and the hypotenuse 1? Because we remember that sine is opposite over hypotenuse. So if they labeled this the opposite side, and obviously the hypotenuse is straight across from the right angle, what would that make the bottom edge? Yes, you need to use the Pythagorean Theorem, and no, you will not come up with a number. You will come up with an expression, and now is the time to do it. Go. Good job. That's the right formula, right? Now I need to actually solve it for you. Must be calling y lower edge. So I need you to solve for it. So let's just focus on label this whatever you want to call it. I need to give myself a letter here. I don't want to so I can set my letter. Okay, so it's y squared.
No, that's not the point. If you're going to break yours, then maybe. How many?
Oh, this is all the same.
Why are you ending that pencil's life?
I guess.
This is the correct answer right here. That is incorrect. It's a lie. You cannot do that because it's not written as a perfect square. If you took 1 minus x squared and factored it, you would get 1 minus x and 1 plus x. Those are not the same. In order to be able to take the square root, it would have to be something like this. 1 minus x quantity squared. Then I could take the square root of it, but it's not. Okay? Okay, so you subtract the x squared.
I mean, you can, but then you
subtract the x squared. And then take a square root. Subtract x squared, take the square root. Yes, that is true.
Okay, several of you labeled it y, although it really doesn't matter what you call it. And you set up your equation, x squared plus y squared equals 1 squared. And so what did you do to both sides? To get y by itself, you started by subtracting x squared, right? So you had y squared equals 1 minus x squared. And then what'd you do? You took the square root, right? Fantastic. You took the square root. Y equals the square. That is not something which can be simplified, folks. The bottom edge is really the square root of 1 minus x squared. You can't do anything with that. It's a difference of perfect squares, if you remember what that was from Algebra 2. And you can't take the square root of the subtraction is stopping you from somehow taking the square root of 1 and the square root of x squared, the subtraction, because you don't have a perfect square underneath it. You have a difference of two perfect squares. The factoring I wrote on the sideboard if you really wanted to look at the math of it and why it won't work. 1 minus x and 1 plus x are not the same. Okay, so now we have all three sides labeled. Okay, before we get to their questions, what? Are we okay? We know what the bottom edge is called now? Okay, before we get to their questions, I want to ask you what the cosine of theta is, the tangent of theta, the cosecant of theta, the secant of theta, and the cotangent of theta. So if I were you right now, that's where I would focus my attention. You got your triangle. Write out your other 5 trig functions.
I never said you couldn't break yours. I just said don't break mine. That was true. You broke yours. The ink would go everywhere. That's what happened.
All right, so what'd you say about cosine? What did we say about cosine? Maybe I should zoom in and redraw my triangle. I wonder if I can fit it in. I don't know if I can fit it in without ruining things. Ooh, that's a horrible looking right angle. Okay, so we had square root 1 minus x squared. Got a little theta down here, an x and a 1. Okay, what'd you say for cosine? Square root of 1 minus x squared all over 1. Now you know and I know that that's just the square root of 1 minus x squared, so if you decided to leave it alone and not divide by 1, it's okay. We know it's still there. Okay, but that's a good answer too. How about my tangent? X over the square root of 1 minus x squared. Okay, how about that cosecant? 1 over x. Secant. Yeah, we're flipping stuff, aren't we? How about that cotangent? Square root of 1 minus x squared all over x. Awesome. That making sense? We're just using our basic knowledge of SOHCAHTOA and Shoshikawa? Okay, now let's go back and look at their composite functions that they're asking me for. What is sine inverse asking me for?
In other words, x went into the, well, whatever one goes in, it doesn't really matter. What does sine inverse always spit out? It spits out an angle measurement. You need to understand that. Okay? That what comes out of an inverse function is an angle measurement. Now, there's only, which angle do you think that is in this triangle? Theta, thank you very much. So the part that they had that I just highlighted in the green, that's theta.
So this question is really sine theta. I think you already have the answer to that. Do we already have the answer to that? Or did we not write it down? I didn't write it down, did I? What is the sine of theta? It's x over 1, right? Or just plain old x. Now, don't get that confused with cosine is the x, sine is the y, tangent is the slope. Yes, I think they made a bad choice on the letters that they picked. Okay, because I can just see it now. You told me the cosine went with x. Why are they saying sine? Sorry, they made a bad choice in my opinion. So the answer to that question is plain old x. Because all they're doing is using the triangle opposite over hypotenuse. Okay, so what's this part inside sine of inverse of x? It's supposed to give you an angle, right? What is it? That part is theta, right? So this question is really cosine theta. So what are we getting? Same thing you wrote down earlier, right? The square root of 1 minus x squared. It's okay if you wrote over 1. It's not going to hurt anybody. This part in here, yeah, that's my theta, so this is really tangent theta. We already have that. X over the square root of 1 minus x squared. I have a feeling you know what the other three are going to be. Because every single time sine inverse x is going back to theta, so the last one, or you got cosecant theta, secant theta, cotangent theta, which we already have the answers for. Because this thing is always going back to theta. So of course this one's going to be that. Of course this one's going to be that. And that one's going to be there. I think the focus of what I'm going to ask you are these questions right here. Composing these that way is not, I feel like there are different composition questions which we are going to do, which are more beneficial in my opinion than those. But knowing the trig functions from this triangle that doesn't have a bunch of numbers for you to plug stuff into. These kind of questions should be easy from your geometry days. These should be easy, right? Okay, which trig function should you use for number 1? Sine, cosine, or tangent? That's a cosine question, right? Cosine theta equals adjacent over hypotenuse, right? How do you get rid of, or how do you get theta by itself? Don't say divide by cosine. Don't you dare say divide by cosine. It's not inverse cosine. Did I just hear inverse cosine? Yeah, that's the way to do it. Right on your calculator. Look at that calculator. Grab that thing. Yeah, for this. Because a 4-function calculator wouldn't do this.
I feel like it's been
I know. What mode should I be in? What mode should I be in for triangles? Degree. Make sure you're in degree. Okay. I am now. Yeah, I saw a few tests that I thought, I'm going to guess that was done in radians. Sure enough, it was. So, cosine inverse of 12/13. And what'd you get? 22.6 degrees. Good enough. Okay, which trig function would you use for question 2? Faster. That's a tangent, right? The tangent of theta equals opposite over adjacent. How do you get theta by itself? Oh my goodness. Take that heresy out of your mouth. Okay, theta is equal to what? How do I do that? How'd you get it? Inverse tangent of 4/13. Okay, This is the easy stuff from geometry that you did. So it's just, kind of reminding you what you should do. How about, and what'd you end up with on that? 17.1. Okay. What about the last one? That is the sine of theta. Yes, is opposite over hypotenuse. So what do you do to get theta by itself? Okay. You say that in the wrong place. You're going to get beat up. Okay, I'm just trying to warn you so that, No, yeah, because they'll come after you. What did you get, 21.8? 41.8? Can I get a witness on that? 41.8? All right, the motion is passed. Sample 6. I got to remember if I think we skipped this one, actually. I think we skipped this one, so strike from the record. That actually is a pretty decent question, but we got other things to worry about, like these. Okay. Not okay. I better. All right. Yep, no calculator. Don't damage the calculator. Seriously. Okay, question 23 says cosine of sine inverse of 1/2. Okay, so let's start with the part in the middle. What is sine inverse of 1/2? First of all, is the 1/2 an x value, a y value, or a slope? That's a y value, right? Now, where on the circle are we supposed to find this y value? Or we're supposed to use this y value to find an angle on this circle.
Horizontally
To the right. Yeah. Right? Do your dance moves. Okay. So we got negative 1/2 right here. We're taking it over that way. Which letter do we land on?
B.
What'd you say?
B.
B? Oh, I thought it was negative, but it's not. I misread it. Yeah, right. It's
Oh,
positive.
it is B?
B.
I just read it. Well, it looked like it.
What angle is that? Pi over 6. Thank you very much. So this part right here is pi over 6.
6 minutes.
Pi over 6.
We did the first step. We found the pi over 6. Now we need the cosine of pi over 6. They're asking me for what? Are they asking me for an x value, a y value, or a slope? They're asking me for an x value. So you're right here. What's the x value? Ah, yeah, it's the one out towards the outside edge, which would be radical 3 over 2. Now there's your final answer for question 23. Okay, how about this? What is the cosine? Start with the inside. What is the cosine of pi over 4? Pi over 4, which letter is that one again? C, right? All right, so we're here at letter C. What's the cosine? That's an x value, right? It is radical 2 over 2, that's right. What's this asking me for? What does the inverse sine always spit out? An angle measurement. So you need to be thinking angle measurement. You know, I get a lot of kids who write down things like radical 3 over 2. Well, they do not understand that the inverse function is asking for an angle measurement. Even some of the questions that were on our previous tests, I got answers which did not make sense. It was asking for a degree measure, and I got radical 2 over 2. And I thought to myself, it's asking for a degree. I mean, it even says blank degrees, and we wrote down radical 2 over 2. I thought, okay, so we don't understand the question because we don't know what it's giving us and what it's looking for. So I'm looking for an angle measurement with a y value at radical 2 over 2 that has to be where? It has to be on the right half of the circle. So what's the angle measurement? Radical 2 over 2 y value has to be on the right half of the circle. It is at the location pi over 4. They basically handed you the answer, didn't they? Now, the only reason they handed you the answer was because the angle measurement was in the range of the inverse sine function already. What if we changed that and made it 7 pi over 4? What if we changed that and made it 7 pi over 4? Okay, which letter choice would that be? Okay, so obviously this is not 25 because I altered the problem. So which letter is 7 pi over 4? Oh. We are at letter choice O. What is the cosine? The cosine is radical 2 over 2. Now look at what you have. Isn't this the same kind of question we just had? The y value, some of you really need to focus. This right here is a y value. The y value, radical 2 over 2, on the right half of the circle. Oh, that is letter choice C, pi over 4. So when you say it gave me the answer in the beginning, that's true, only because the original angle was already in the range of the inverse sine function. 7 pi over 4 is not in the range of the inverse sine function, so it was going to spit out an answer that was different than 7 pi over 4. You must do this one step at a time, and yes, you need practice, I understand. Okay, which is why I'm practicing with you now. I know some of you are extremely hungry. But you need to start inside and work your way out. So as you're working on these, including next week when I'm gone, I'll be here Monday, but I'll be gone the rest of the week. Then you will have to spend time working with each other on these kind of questions. And I understand we're about ready to go to lunch. So starting another one is probably futile.